In the previous video, we finished off our encapsulation challenge. In this video, we'll make a start on polymorphism. I've said it before that simply stated, polymorphism means many forms. You might be wondering, how does this apply to code? Polymorphism in Java allows us to write code that can call a method, but the actual method that gets executed can be different for different objects at runtime. This means that the behavior that occurs during program execution depends on the runtime type of the object, which might differ from its declared type in the code. For polymorphism to work, the declared type must have a relationship with the runtime type. Inheritance is one way to establish this relationship, where a subclass can override a method from its superclass, enabling polymorphic behavior. There are other mechanisms to achieve polymorphism, but in this discussion we'll focus on using inheritance to support polymorphism. Previously I touched on this concept in the inheritance videos, but now we will delve into polymorphism specifically. Hopefully by now you're getting more comfortable with class diagrams. This time we're going to look at a polymorphism example using movies. I'll have a base class of movie which has the title of the movie, and movie will have one method, watch movie. I'll have three subclasses, each a different kind of movie. I'll have an adventure film, a comedy, and a science fiction movie. These are the different categories, so I'll use these as the subclasses. All of these will override and implement unique behavior for the watch movie method. I've already created a project called polymorphism with the usual main public class and main method. I'll now create the movie class. And I'll add my one field title as a private field. And next, I'll generate a constructor using our newly created field. And now let's add the watch movie method. This is the public method that's going to be called from the outside world, or the calling code. And this is the method that I'll be using to demonstrate polymorphism. It's void and has no parameters. String instance type equals this.getClass parentheses .getSimpleName parentheses, and I'll print the title and instance type. Now here, on the first line of this method is something new. You've seen the use of the keyword this before, which refers to the current instance, and now I'm calling a method on that called getClass. The method getClass is on java.lang.object, which we've talked about previously. This method returns class type information about the runtime instance on which this method is executing, and from that I can get the name of the class using the getSimpleName method, and here again I'm just using method chaining for convenience. This prints out the class, which will be movie if I execute this method on a runtime movie object. But when I implement the subclasses and run this method, the runtime object could be an instance of one of those classes, the adventure class for example. This will hopefully make more sense when we run this code. Next, in this code I print out the title of the movie and the type of the movie runtime instance, and that's the movie class. Let's go to the main method on main class and test out the watch movie method. The movie equals new movie and Star Wars as the argument. The movie.watchMovie. And running that, I get the output that Star Wars is a movie film, and that's because the runtime instance of the movie variable is the movie class. It's the object I created here in the main method, and I did new movie, which means it's really an instance of type movie. Here, I've created the object using the new movie statement and passed it the title Star Wars. Okay, so no surprises there, I hope. What I'll do next is add some subclasses of movies that represent different genres or classifications of movies. You can think of these as the way a streaming company would group different movies. I'll start with the adventure movie type. I'll add this class to the movie.java source file, and I won't give it an access modifier, meaning it has package or default access, but I'm going to have it extend movie. Class adventure extends movie. This doesn't compile yet because I need to add a constructor. The adventure class has no fields of its own, but we need to set the title, which of course is in the movie class. To add a constructor to achieve this, I'll select code, generate constructor, and I get the generated constructor, which uses movie's field title as a parameter and makes a call to super using that argument. Now I've got the constructor, and an adventure movie will get created with just the title of the movie. Next I want to override the watch movie method for the adventure class. When you're overriding a method, it's a pretty good idea to start with IntelliJ's override generation tool. This ensures that your method signature is right, so let's do that for this class. Placing the cursor below the constructor, select Code, Override Methods, and select the Watch Movie method on Movie. And that gives us IntelliJ's default generated code, which includes the @override annotation, which we've seen before. This method simply calls the method on the movie class, which is the super or base class for Adventure. That's good, I want to do that, but I want to include extra functionality that's specific to the Adventure class, like output some of the major plot stages of an adventure film, for example. I will just use the printf method and the repeat method on string to print out the plot stages. The literal string passed to printf is as follows. I'll add .repeat to that string and pass 3 as the argument. I'll add pleasant scene, then scary music. And of course I'll add something bad happens. Let's talk about this code for a moment, because here I'm using the format specifiers %s and %n. The format specifier %s is used to replace any string, which is not as commonly used as others I've shown you, but it will work well here. And I've said before that %n puts in a new line there. Now this string gets repeated 3 times with this repeat method before the formatting takes place. This means that all these stage plots get printed each on its own line. Now let's go back to the main method and test out the watch movie method on an adventure object this time. And what I can do here is simply replace this new movie statement with new adventure instead. I don't have to change the type of the movie variable, it can stay as movie. And this is because adventure is really a type of movie, a subclass. And inheritance lets me say adventure is a movie. This code compiles and I can run it. And now look what happened. The code ran the watch movie method on the adventure class. That's because at runtime, the method that gets run is determined by the Java virtual machine based on the runtime object and not this variable type. That right there is our first taste of polymorphism in this code. I've declared a variable of type movie and assigned it an object that's really an adventure type of movie. And when I called watch movie on that, the behavior was the adventure movie's behavior. It wasn't just the base class's behavior. The method that's on the adventure class first calls movie's method, which is why we see that first statement, Star Wars is an adventure film. But this time I get the text that this is an adventure film there, and this is the actual type of the object at runtime. And then I have the plot stages for an adventure film, pleasant scene, scary music, and the last one, something bad happens. And that's a really simple example of polymorphism. Let's keep going and building on this. Getting back to the movie.java source file, I'll create the comedy subclass next. And what I'll do is copy the adventure class and paste it directly after that class. If you close the class node, copy and pasting is a little easier. And I can expand the pasted class node. I'll change the name of the class to comedy. I'll change the constructor to comedy. And I also want to change some of the stages for the plot to some that make more sense for a comedy. Maybe the first stage is something funny happens, and the second one could be something even funnier happens, and maybe the next and last stage could be happy ending. I can really do whatever I want in this method, but right now I'm keeping it simple. But I could call other methods having many more stages to the plot or whatever I wanted to do. Okay, I have 2 of my movie subclasses built, but let's do the last one, which I'm calling science fiction. Again, let's just paste the adventure class below the comedy class and then change the name of the class to science fiction and change the constructor to science fiction. And then I'll change these 3 stages to make more sense for a science fiction movie. So let's say bad aliens do bad stuff is the first stage. Then space guys chase aliens after that. Then finally, planet blows up. And that's the science fiction class, which means now I've built the movie class and all of its subclasses. Let's just expand the adventure class so I can see its code. Since this video is starting to get a bit long, I'm going to stop it here. I've created an inheritance hierarchy with movie and 3 subclasses. I've assigned an adventure movie instance to a movie variable reference and saw that when it ran, Java figured out which method to run, not on the compile time code, but on the runtime instances method. In the next video, I'll pick up from here and show you what you can do with polymorphism.